In example 3, we are graphing using transformations, which is a shortcut to graphing functions that have a parent graph associated with it. And the parent graphs that you will be using are x squared, x cubed, the square root of x, the cubed root of x, the absolute value of x, and I'm not sure if I missed any, but those are some of the ones that we will be using. And so I see that I have a parent graph associated with this first function, and the parent graph is x squared. And I'm going to use the basic shape of x squared to help me graph this. Now, you don't have to do this, but for just the example, I am going to do this. I'm actually going to graph x squared. So those points you should have memorized are 0, 0, 1, 1, 1, 1, and then 2, 4. And then on the other side, negative 1, 1, and negative 2, 4. And then it looks something like this. It's not going to be perfect for me, and I'm not going to get a good curve because it's hard to do this with a tablet. It's hard to do with a pencil, let alone this tablet, but that's close to what the graph of x squared looks like. Not as wiggly probably, but close enough. And now we're going to go ahead and graph using transformations. We're going to graph x squared minus 6. X squared minus 6 is my parent graph of x squared that you see in red, transformed and moved down 6 units. It's literally the red x squared, same shape, same direction, opening up, but moved down 6 units. So what I do is I take my origin and I move it 6 units down. So 1, 2, 3, 4, 5, 6 units. That is going to be my new origin, and I'm actually going to pretend that that is my XY axis. And again, you don't typically do this when you're working out homework. I'm just using this for demonstration, drawing in these lines for demonstration. And ignoring all the numbers that are there, all the numbers that you see, negative 4, negative 5, negative 6, I am just going to pretend that that is my regular origin that I used up here for my red graph, and I'm going to draw in the shape of x squared. So it's over 1, up 1, over 2 spaces, up 1, 2, 3, 4, back 1, up 1, back 2 spaces, up 1, 2, 3, 4. And then I'm going to go ahead and try to draw a smooth curve, which really looks like a V, but shouldn't. So you can just pretend I did a better job on that. And you can see that my blue graph is literally the same shape as the red graph of x squared, except it shifted down 6 units. When you have a number being added or subtracted, and it's after your function and not nested in parentheses or anything like that, then that is an up and down shift. So technically, I could get rid of that red graph and get rid of that piece. And I don't need the blue dashed lines in there, but if I try to delete them, I'm going to end up deleting my whole graph. So I'll just keep them in there. But this is like the real answer to the problem right here. It is regular x squared, same shape, just moved down 6 units. So if you have that parent function memorized, then you can very, very quickly graph any associated graph without having to do a complete XY table or put it in your graphing calculator. It just takes like 2 seconds to graph. All right, let's go ahead and look at the next one. I see that I have the absolute value of x minus 4, and the parent graph associated with the absolute value of x minus 4 is the absolute value of x. So this is the graph that we are going to be using. We're doing the parent function absolute value of x, and that just looks like a V. So let's go ahead and graph it. If I were graphing plain old absolute value of x, I would have the point 0, 0 at the origin, then over 1, up 1, over 2, up 2, over 3, up 3, and so on. And then on the other side, it would be symmetric, back 1, up 1, back 2, up 2, back 3, up 3. And then you can just go ahead and graph that in. That's the parent function. Now my transform function is the absolute value of x minus 4. And you can see that it's different than example A because the minus sign is on the inside of my function. It's within those absolute value symbols. It's not like tacked on the outside of the problem. If I had a minus 4 out here, then that problem would look like example A, but it's different because the minus 4 is on the inside of the function. So that is a different movement. That is actually a left-right shift, and it's opposite of what you think it's going to move the graph. It is not moving the graph to the left, it is a movement to the right. And this, if I have any issues with graphing, if I'm doing an answer key very quickly, this is where I'm going to have an issue. If I'm working fast, then I might accidentally move my graph to the left, and it really should be to the right. So if you have a plus or minus number on the outside of your function, then that's an up and down shift, and it is what it is. If it says minus 6, go down 6. If it says plus 6, go up 6. But within your function, if you have a plus or minus number, it's going to be opposite of what your gut is telling you to do. And so we need to move right 4. So I'm going to count 1, 2, 3, 4 spaces. That is going to be my new origin. I take my original origin, which is 0, 0, and I move it over 4 spaces. And then you do not need to have the dashed lines in. I don't even know if I'm going to be able to do the dashed lines because it seems like my it's not cooperating. There we go. All right, so there's my new origin, and I'm pretending that that is 0, 0, and I am going to graph the absolute value of x just as we graphed it in red. And I'm going to go from my new origin over 1, up 1, over 2, up 2, over 3, up 3, just ignoring all the numbers that are there, pretending they're not even there, and graphing it as though this was the origin. And then we do back 1, up 1, back 2, up 2, back 1, 2, 3, up 1, 2, 3, and then connect. So literally we have our absolute value of x function shifted to the right 4 units. And by memorizing that parent graph, and by knowing the basic shape, instead of having to do an XY table and taking a long time to get my ordered pairs, I can very, very quickly graph this related function. I'm not sure if I'm going to be able to do it, but see if I can get rid of that red graph. Just the red graph. Not sure. Bingo. Got it. Okay. So really the answer to the problem is just what's in blue. You do not need to have these dashed lines in there. But I think if I try to get rid of them, yep, I lost my whole graph. This isn't the most friendly way to do a video, but it's definitely convenient. So anyway, that is the absolute value shifted to the right 4 spaces. Okay, so let's continue onward. I did switch programs to one that I don't like as much, but the other one was driving me crazy. So hopefully this one works a little bit better. All right, so I do see a parent function associated with C, and it looks like it is the square root of x. So if you take away the 2 and you take away the 5 and you take away the negative sign, we've got f of x equal to the square root of x. And that graph, when you normally graph it, goes from 0, 0. It goes over 1, up 1, then over 4, up 2, and looks like that. And so we need to move our function based on the shifting that it's telling us to do. I see that I have a +2 on the inside of my function underneath that radical symbol. And when you have a number being added or subtracted on the inside of your function buried within some kind of symbols, then that is going to be a left-right shift, and it's opposite of what you think it should be. A +2 is actually a left shift of 2, not to the right 2, but to the left. And then we have another number being added on the outside of the function, and when you have a number being added or subtracted on the outside, it's an up-down shift, and it is what it is. If it says +5, you're going to go up 5. And then finally, we have a reflection here with a negative sign out front. That is a reflection over the x-axis, and whatever y value you normally would have, it's going to be opposite that regular y. So instead of going like up, you would go down, or instead of going down, you would go up. And instead of saying reflection over the x-axis, I usually just write the word flip if I'm doing an answer key to remind myself, don't forget to do that. If it's not fancy enough for you, you can say reflect x. If you have the negative on the inside of the function within parentheses or a symbol, if the negative's next to the x on the inside, then that's a reflection over the y-axis. So just remember, on the outside it reflects over the x-axis. Okay, so let's go ahead and move our origin. We are going to move left 2 and then up 5. 1, 2, 3, 4, 5. And my new origin is up here. And the regular square root of x function would be, I'll just show you where that would go. It's 0, 0, 1, 1, 4, 2, which should be memorized. And if I move that up here, I'm going to stay in red for a second. If I move it up to my new origin, once again, I go over 1, up 1, over 1, 2, 3, 4 spaces up 2, and it gives me that same shape. But I do have to remember that we are reflecting over the x-axis, and whatever our y value is, it's going to be opposite. So normally my y value, when I go over 1, I go up 1. I now have to go over 1, down 1. Okay, so here's our new origin. This is the official final graph. It is moved left 2, up 5, and then we have a 0, 0. We have over 1, down 1 instead of up, and then over 1, 2, 3, 4, down 2 instead of up 2. And then here is our final graph. Now, if we had a negative underneath that radical, then our graph would have like swung that way as well. But we don't have it there. It's on the outside, which reflects over the x-axis. So the only thing that you need on your paper technically is the blue. Move left 2, up 5. Graph the square root of x, but make sure it's flipped over the x-axis. In fact, it's flipped over our fake x-axis that's up here. Not the real x-axis all the way down here, but it's flipped over and reflected over our new origin or our new x-axis. All right, let's see if I can find an eraser. So we don't need any of this technically. If you need to draw on this extra stuff when you're doing your homework, then just make sure that your final graph is really, 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 really bolded. Make it pop. Color it in with a different color. You don't necessarily have to erase all the other stuff if you don't want to. If it helps you to draw in your new origin or the original graph, go ahead. Just make this one pop because this is actually the final answer. All right, last example on this page is f of x equals 1 over x minus 3 minus 4. I think that was supposed to be a 1. I'll double check it before I post the video, but I'm sure it's just a 1. Okay, so let's go ahead and think about what the parent function would be. If I took away the 3 and I took away the 4, it would be 1 over x. Now 1 over x is kind of difficult to graph, so when we're doing it, we can do like a super duper simple sketch and not put in all the half points. So if you're just doing regular 1 over x very quickly, you are going to go over 1, up 1, put a dot, and then draw in your curve like that, and then left 1, down 1, put a dot, and then draw in your curve. The other ordered pairs that are halvesies, like back 2, down a half, back a half, down 2, over a half, up 2, over 2, up a half, like that is just too much. Takes too long to graph, so this will be acceptable for a super quick sketch. All right, so let's go ahead and figure out what our shifts are. And it looks like on the outside of my function, way after the 1 over x is written, I have a downward shift of 4. And this minus 3 is underneath the fraction bar. It's contained within that function. So that is your left-right shift, and that is opposite of what you think it should be. It's actually to the right 3. And let's go ahead and then just find our new origin. I don't have any flips or anything or reflections. So I'm going to move to the right 3, 1, 2, 3, and down 4. 1, 2, 3, 4. My new origin is right here. And then the original function would just be over 1, up 1, swing it like that, and then left 1, down 1, just swing it like that. That's the original one, but we want that graph in our new origin. So I'm just going to pretend that this is the real XY axis. I'm going to ignore all the numbers that are on the old XY axis, and this would be my 0, 0. So from our 0, 0, our new pretend origin, I'm going to go over 1, up 1, and put that dot, and then just kind of sketch in my graph, very basic, and then back 1, down 1, put in my dot, and again, just put a quick sketch. Now, if you want to get fancy and you want to put in the other remaining dots, it would be back 2, down a half, back a half, down 2. That would actually make my graph a little more accurate. Over a half, up 2, and then over 2, up a half. But I'm not really requiring that. All I really care about is that you get that first key point on either side, the 1, 1, and the -1, -1. And then once again, really make your final answer just pop by darkening this in, or you can erase all the other lines that you put in to help you do your sketch, or maybe you just don't even need them at all. Maybe you can just draw that new graph like right away, and that's fine. That's great if you can do that.